Ryan Buetow is from NDSU, where he did his undergrad in crops and weed science and has done his master's degree. He's currently finishing up a PhD and is working full-time for NDSU Extension. He started working at the Dickinson Research Extension Center in 2015. He's from a farm just outside of the Twin Cities in Minnesota, surrounded by corn, soybeans, alfalfa. I love this. He enjoys the crop diversity of southwestern North Dakota. And he works with a wide range of cropping systems, spending a lot of his time on what we may see as an emerging issue, maybe in Manitoba. Certainly you viewers in Saskatchewan and Alberta are a little further down the road on this. So I'm very glad that you're here today to talk to us about your work with soil acidification and trends. Ryan.
All right, I like to move around a lot, so I'll do my best to stay put here. So, all right, there we go. So, soil acidity. A lot of you are like, well, I've got high pH, I don't need to worry about this issue, right? How can I acidify my soil quicker, right? You know, this issue, it caught a lot of people in North Dakota off guard because typically we haven't had to worry about acidity. We're dealing with 7s, 8s for pH quite often. So to start out, I just want to kind of clarify some terms. Sometimes there's a little bit of confusion when I talk about this and people mix up salinity and acidity. They do kind of sound alike sometimes. But I will be talking about acidity today. That's low pH. And a lot of times what we're dealing with is acidity from nitrogen use. Because it's nitrogen use, people sometimes think of salts. Because their seed gets damaged by salts from fertilizer or something like that, or you have landscape salinity, which is really a water management issue, right? So, and then you have sodicity as well, which is more of a dispersion, soil dispersion issue. But anyway, so this is salinity, not acidity. So I'm not talking about those white spots in fields. Acidity, really what we're seeing is anything below 5.6. I've seen as low as 3.9 out in western North Dakota. And this has a lot of impacts on different things, okay? So there's a couple different ways you can get low pH soil. We do have some landscape acidity, on side slopes and that kind of stuff. But what I'm really talking about here today is acidity formed by nitrogen fertilizer. Right? So in reduced tillage systems especially, you're applying nitrogen in a very consistent spot year after year. And nitrogen, when it changes forms in the soil, releases hydrogen ions. And, when it changes into the form the plant can use, right? You release some hydrogen. And, different nitrogen fertilizers are going to acidify at different rates. But you're going to see some acidification from nitrogen fertilizer. If you have enough buffering capacity in that soil, if you have a lot of calcium carbonate in that soil, you might not be seeing this issue anytime soon, but we are seeing this issue in spots that have historically had higher pH. So different nitrogen sources are going to have different levels of acidification. AMS is one of the bigger ones, up to 5.4 pounds of lime required for every pound of nitrogen in that form of AMS. MAP fertilizer, right? So we don't think about the nitrogen in MAP too often, but in 1152O, for that 11 part right there, for each pound of nitrogen in MAP, we need 5.4 pounds of lime to neutralize that acidity, right? So let's say we've been no-till for 10, 20 years. Every year, a little bit of that's being put down. We haven't been putting any lime down because we historically have a high pH. All of a sudden, we have this band of acidity 2-3 inches down in the soil, and it can really add up over time. And it can be hard to pick that up in a composite soil test if you're doing a 0 to 6 inch or deeper. So when we're doing this stuff, we're trying to, for pH, we're trying to test at least a 0 to 3 inch zone. But yeah, so this is something to think about, especially if you're working in a reduced till system, and even in tillage, depending on the type of tillage. Often, if you're tilling down to 6 inches, really only 3 inches of soil is being worked. But again, there's a lot of factors that play into this. So no situation is the same across producers or regions, but acidity can happen in high pH fields. And, who cares, right? Well, there's a lot of factors that, pH is like the master switch for all these different functions in the soil, right? So you get a lot of different nutrients that are no longer being made available. Phosphorus, we just heard a little bit about phosphorus, right? Once that pH drops below 5.5, aluminum becomes more soluble, right? So there's aluminum in our soil, but the plant can't access that aluminum, right? So all of a sudden, you have this acidification happening, aluminum becomes available, but it also kind of ties up that phosphorus, and all of a sudden you have plants taking up aluminum. If you notice on the top there, fungi don't really seem to care too much, but bacteria do not like acidity, right? So if you get into the soil health world a little bit, they care a lot about the microbiome, but if you're growing any pulses, any legumes, why do we care about bacteria? We need nitrogen fixation, right? Do we get nitrogen fixation if our bacteria aren't active? No, right? So legumes get hit twice as hard in this issue because that aluminum becomes more available and you get aluminum toxicity, but also you're starting to see issues with your nitrogen fixation. So that's definitely a concern. There are some differences in how different crops can handle aluminum toxicity, but it looks like a stubby root. I think a lot of you are probably familiar with club root and canola, right? It looks a little bit like that. You get this stunted roots. A lot of the ends kind of get stubbed. You get reduced root structures. You get reduced growth, but there are some differences in variety and how that goes. But it's not great, right? And this is a photo taken by someone from our NRCS service. Soybeans really don't like this issue. You can see this is on the left. The pH is 5.1, which is still not great. But the plant on the right, it's kind of that progression into a 4.5 pH, right? So as that becomes more acidic, that plant becomes more stunted, the root system becomes more stunted, and you definitely see some yield loss there, right? So you can get stunting, and in some severe situations, you can see complete stand loss. This is a drone picture I took this summer with sunflowers. So you see on the left, that stand is greatly reduced, and on the right, that stand, the stand isn't that much better. It's not great. The thing is, it's not like there's any differences in elevation. There's not really any differences in soil type. I did send some samples into AgVise, and I did some kind of some testing around out there. And on the left, with my self-testing, I found spots as low as 3.9 over here. There were some very large gaps in the sunflower stand. And on the right, it was typically, above 5.1. I think the composite that I sent into AgVise from this side was around like 4.8, and the composite on this side was around, I think it was 5.1. So we found the threshold for sunflowers, right? So you had stand loss on this side, on the left side, and you had some, it didn't seem to affect it too much at that 5.1 for sunflowers, but that's some pretty severe stand loss. And when we're talking about yield, we're talking about stand, head size, and seed size, right? So you have these reduced stands, and then the heads that are there are so stressed that they're not growing like, sunflower can often make up for some stand loss, but we weren't seeing that in this spot. So just a lot of stunting going on. and it's just not great. There's a lot of crops that don't do well, but yeah, once you get down to pH in the 4s, there's not a whole lot of things that do well. Okay, so we also care about this because our herbicides are pretty heavily impacted by pH, right? So pH, we normally think of chemistry. We're applying chemistry out into our fields, right? So some herbicides will persist longer at a low pH. Some herbicides will be less active at a low pH, right? So there's a couple different things that you need to think about. Yeah, so I mean, you talk at like an SU is going to be more persistent at that higher soil pH. So you have some differences in your half-life going on. Your IMIs are going to be more persistent at a lower soil pH. So you can see some carryover issues there as well. So here's a soil pH of 4.6 at the top there, and that's the herbicide remaining on the left, and on the bottom is the amount of time that it's there, right? So you can see some differences going on. Those are pretty big impacts, especially when you're trying to plan a diverse rotation. You can definitely see some issues with your weed control, and oftentimes, my soil scientist colleagues, I'm an agronomist at the end of the day. I know enough about soils to be dangerous. My soil scientist colleagues tell me that these are the spots in the field where you're supposed to find acidity. Well, that's not what the field shows. We can find acidity anywhere in the field because this is a management issue, right? So, oftentimes I can find these low pH sites by finding certain species of weeds out there, certain grasses that aren't dying. Things like green foxtail can handle, they actually grow better in acid environments, right? And then atrazine can also show some different, some issues as well with pH. So I don't want to spend too much time on that, but yeah, you definitely need to be thinking about your herbicides. Even if it's just a small spot, an acre here or something like that, that can have a difference when it comes to things like herbicide resistance. If what you thought was a high rate was actually a low rate, you can kind of breed for resistance in some of these situations. So you got to be careful with your pH, especially since those herbicides are being applied at the surface in a lot of situations. And if we're not managing that surface pH, we can run into some issues. And we've been finding more and more of this issue. So I'm in, let's see here if I can get that to work. Anyway, so I'm kind of in that southwest corner of North Dakota. This is a map of North and South Dakota. Early on, a lot of people were like, well, that's a West River issue. We're not going to see this, where we are. And we pulled a lot of samples across North Dakota, and we did find quite a bit in eastern North Dakota. And we found even more as we continue to look around and just ask no-till producers and reduced-till producers. And we found this as far northeast as Park River, North Dakota. There are guys in Minnesota seeing acidity that haven't typically seen acidity. This is a major issue in Montana, Idaho. I know that there's some guys in Saskatchewan that have this issue. Anywhere that there's been no-till across the world, we're seeing stratified soil acidity. So we need to, just because we haven't had this issue in the past, we need to kind of get past that, right? And be looking for this. I'm not saying every acre has it, but especially in reduced till systems, you need to keep an eye out for it. And the answer to it is pretty simple. You just got to lime. Now, if there's a lot of areas that haven't had to lime historically, the infrastructure isn't there for liming, it is costly, and if a farmer's never had to apply lime and their fathers never had to apply lime and their grandfathers never had to apply lime, they don't want to apply lime. So we're trying our best. On top of that, a lot of the lime that gets put out there is worked in. These are reduced till systems, so they don't want to have to do that. And it gets kind of tricky because not every cropping system is the same. Some guys are putting their nitrogen at the surface, some guys are putting it down deep. And because of that, we're seeing acidity at different levels in the soil profile. So It's kind of complicated. We don't have, I mean, with any research, we have more questions than answers, but we are doing some work on different liming rates. A lot of the surface applied liming work has been done in greenhouse potted trials. No-till soil has a lot of macropores, crooks and crannies, a lot of soil aggregates. So there's going to be some differences in the soil physics with no-till, especially if you dig it up and put it into a pot, right? So because we're working with that surface issue, we need to make sure that we're doing this stuff out in farmers' fields. So we spent a lot of time driving around North Dakota with hula hoops, and people probably thought we were a little crazy, which is fair. But we were putting these little trials out in farmers' fields in different environments, different rates, and we're trying to see what kind of rate you can put out there and how much you can actually get to dissolve in that growing season. So far, we found about 2 tons will dissolve in a growing season. There's still a lot of work to be done on this, but there's some situations where the soil pH at that 3-inch mark is 3.9, 4.2. You're not going to be very productive with that. So, incorporation is maybe an option, but a lot of these guys are very proud of their no-till practices, and that incorporation component just isn't there. So we're trying to find some options for guys to give them time to see, ideally this is a surface application every once in a while and not a every 3 years kind of thing. But there's so many factors like your soil type and management that can really impact how effective that's going to be. And rainfall is a huge component of that, and we've been very dry out west. So something to keep in mind. But we've been working on it, and we've been trying different things. This is a picture of a trial we have in southwestern North Dakota. We got 12-acre plots, and we have different cropping systems across 4 different plots, and then within that we have 4 reps of different lime rates that were applied with a commercial spreader. And those are going kind of crossways from the way that the crop is planted. And you might be able to see a dark patch, a dark strip in that bottom corner of the sunflowers there. That was where we tilled. So we did do a tillage pass, and it looked a lot darker green, looked really nice early on. And then, as happens in western North Dakota, the water turned off. And so it got very dry. So it looked great early on, that tillage pass, but we lost those benefits of no-till. We lost that good water holding capacity. Those sunflowers dried out pretty quick, and we definitely saw some yield loss in that tillage pass. So there's a short-term loss of being able to handle drought, but I think that you're going to get much more effective and quicker lime actually doing its job with that tillage pass. But there's trade-offs with everything we do in agriculture, so that's going to be up to the farmer in these situations. But as I said, there's a lot of people just not wanting to lime in the first place. So, there are ways to kind of get around that. So what we've been kind of dealing with is Band-Aid approaches, stuff for rented acres where guys don't want to put the investment in, or if they did apply lime, that lime doesn't work right away. So we need something to get by while that lime hopefully works its way into the soil, which is going to take time with the surface application, right? So there's different species that do better, and some species we know don't do well at all. You get alfalfa in a soil below 5.5, and you start to see a lot of issues. Alfalfa does not like low pH, and pretty much all legumes don't like low pH. So, but alfalfa gets hit really hard. Even though it does grow through that zone eventually, that aluminum toxicity really does damage it early on, and you can see some major stand loss when you're trying to get that stand established, right? So, there's a lot of thought processes that happen where people are like, well, it's going to grow through it, so it'll be fine, but that's just not the case because we're planting right into that acid zone. So there's a lot of things that happen in those first couple of weeks that get pretty heavily impacted, right? So just because it grows through it, eventually, if you don't have a good stand establishment, you have some issues. Safflower gets impacted really badly, and Durham's probably one of the most sensitive crops out there to this issue. Wheat, spring wheat, hard red wheat. There's differences in varieties. I know winter wheats are typically better prepped for this type of issue, and that more has to do with where a lot of those are bred. Oats do really well in low pH. They can just kind of seem to handle the aluminum toxicity better. So, and then I heard some talk about teff earlier. Teff is supposed to be pretty well able to handle this issue, but getting it established can be difficult sometimes. So, all right. So, species selection is important. There's some pretty major differences in how that's impacted. And then within those species, right? So you see a wheat high in the orange and a wheat low in the yellow. That species selection and that cultivar selection is very important. So we know for sure there are wheat cultivars that do well. So we've been doing quite a bit of work with wheat because we grow a lot of wheat in southwest North Dakota, and it's a good way to help deal with this issue, especially with these short Band-Aid approaches that don't necessarily fix the issue, but you can still be productive, right? So we did some work with varieties. Since 2018, we've been doing some trials, trying to look at yield, trying to look at tissue samples. We do know that there are some varieties that do better than others. We've tried a few different commercial varieties, and it's not always consistent because it's not always just one issue that we're seeing out there. But there are varieties. I talk about Soren a lot. Soren is a variety that's done really well for us, but you put it in low pH situations and it does horribly. So we've been using that as kind of our control. And Lanning out of Montana, it doesn't have the best disease package, but it can handle aluminum toxicity. You put it in a low pH soil, and you pull a plant out that was planted the same date as a plant in a neutral pH, and those plants look exactly the same, right? But you take Soren from low pH and compare it to a plant grown in neutral pH, and it's about half the size and stunted and yellow and gross looking, okay? So variety can make a huge impact, and we're especially in North Dakota, our breeders are looking very closely at some of these genes, and there's still a few different pathways of resistance for this aluminum toxicity and other issues that we're still learning about. So variety is a great way to deal with this in the short term, but we're not fixing the issue, and that's the biggest thing to keep in mind. Talked a little about phosphorus, right? So there's trials done in Kansas, Oklahoma, Montana. I really like this one because it shows how big of an impact this low pH has, right? So on the top, you kind of have that dashed green line and the green yield marks there. So the durum there was grown in a pH of 6.1. It had been limed with 5 tons per acre and worked in. So they fixed the pH there. It's above 6. All right, so that durum was yielding about 46 bushels. That blue line, that was durum in a pH of 4.4, right? So all of a sudden you see an increase in yield. So this was fertilized for phosphorus to the recommended rate, and then they added more phosphorus in furrow on top of that recommended rate, okay? So at 60 pounds of additional P2O5, that's not 60 pounds of product, that's additional P2O5, that additional 60 pounds, they were able to get the same yield as that limed field, right? So I don't know about up here, but phosphorus isn't necessarily cheap. And I don't think I want to put 60 additional pounds of phosphorus with the seed. That's a lot of product. This trial was done with triple superphosphate. So we replicated that out west, and so we added 130 pounds of product, so around that 60 pounds of P. In 2021 we had a very dry year, but we still had a low CV. I'm pretty confident that it increased the yield. That's across varieties, but it was only a 1.5 bushel increase. And then this past year we did increase the yield by over 10 bushels, or about 10 bushels. It looked like night and day with and without phosphorus. So that phosphorus is important. This is with spring wheat, it's very obvious with durum as well, and I think you could even go a little bit lower than that 60 pounds raised depending on yield potential and moisture and that kind of stuff. But we know phosphorus works, we know varieties work. And then there's a lot of guys, this is a relatively new issue, so guys are trying different things. Maybe some things are being pushed that shouldn't be. So yeah, there's some things that people have tried. My trials haven't showed them working at all. We've tried some PGRs. We've tried, different seed treatments, some foliar stuff. We tried a humic acid. Doesn't really seem to do anything. There's some work out there saying that sulfur can turn it into aluminum sulfate, and the plant can handle that form of aluminum better. I haven't seen anything with that. Guys are pushing low rates of lime in furrow. That doesn't seem to do anything. Lime works, but a low rate of lime, anything below 400 pounds is basically worthless when it comes to lime. We need tons of lime to really do anything. And I've done a little bit of work with biochar. Biochar at 8 pounds, it cut the yield in half. So then the next year I put it to 4 pounds, and it increased the yield. So I don't know what's going on with biochar. But there's something. There's ash in it, so maybe that helps, but there's also potentially some metals in there, and acidity can have an impact on metals. So, and then there's any amendment other than lime is just a short-term Band-Aid. You can't. If you don't fix the issue, you're going to continue to spend money on things that aren't getting used to their full potential. So, we tried calcium in furrow, we tried gypsum in furrow, we tried calcium nitrate in furrow. Those things don't do anything. Phosphorus works. Perennials, there's Mark Liebig had something showing that perennials can slightly increase the pH. This trial was started before it became highly acidic, but he did show they're seeing some things there. The biggest difference is that you're not adding the same amount of nitrogen and you're not acidifying things as quickly. Right, so there are some benefits. If a guy's close to retirement and doesn't want to apply lime, you could probably put something into perennials. There's been some work done in Montana. There's things like slender wheatgrass, intermediate wheatgrass. A lot of the things that do well in salts also seem to do relatively well in acidity, so there are some perennial grasses that you can put out there. So you can find that on Clayton Jones's website if you want to try to find more on that. But a lot of the kind of native type grasses can seem to do well in acidity in some situations. Big bluegrass, We've also been trying to do some stuff with livestock integration, so seeing if that hoof action does the same effect on working the lime in as tillage. This kind of stuff takes time, so we'll see. Just trying some different approaches. But yeah, it's definitely an issue for us, and we're starting to see it's more and more of an issue. If you just Google or use your favorite search engine and search NDSU, what is soil acidity? We got a small publication that just kind of explains some of this stuff for you. If you're seeing a weird spot out there, I would start paying a little bit of attention to pH. Especially, we first started noticing it along field edges where maybe nitrogen got doubled up every year. Just some differences like that. If you're noticing areas where weed control isn't happening to the best of its ability, it could be herbicide resistance, but you don't want to rule out pH. It's a very easy thing to check. So that should be part of your troubleshooting, especially if you're working in reduced till systems. We've been splitting that sample because 0 to 6 might show that the soil's at a 6.1, but all of a sudden that 0 to 3 is in the low 5s or even lower, right? And that can have some major impacts on our nutrients and our herbicides. So just something to keep in mind. I know high pH makes you think that this is not an issue for me. I've been in fields where there's pH of 8 in one spot. I go to another spot and it's 4.2. Okay, so fields, some fields are pretty consistent, but management isn't always consistent across those fields either. So just keep an eye on things, check for pH when you can. We know cultivar works, we know phosphorus works, we know lime works at high rates, but we're still working on the logistics of surface application, okay? With that, any questions if I got time?
Oh, okay.
Canola looks just like group 2 injury. Also with canola, you can see manganese toxicity. A lot of times this will often look like a phosphorus deficiency or some kind of herbicide issue, and it could be aluminum toxicity or manganese toxicity. A lot of times the canola kind of grows through it, but you can see some herbicide issues there too.
And are they working in Manitoba or Canada for breeding on varietal changes so that we decrease that sensitivity to the pH or the toxicity? Do you know? Anyone know?
I don't know if Manitoba is. Is anybody here?
I also had a question about whether hoof action was actually your technical term or something you coined yourself. We are now going to.
breeder in the house?
No.
We'll park that question.
Okay, so you need to talk into the mic, John.
All right, thank you.